Welcome to your Finite Math R6 lesson on exponents. So the objective for today is to simplify expressions using the properties of exponents. Okay, if you'll recall, x to the first power equals x. So if you just see some variable and you don't see an exponent with it, it has an exponent of 1. If n is greater than 1, then x to the nth power is equal to x times x times x times x n times. If x does not equal 0, then x to the 0 power equals 1. So any other number than 0 raised to the 0 power is 1. If x is not equal to 0, then x to the negative n means the reciprocal of x to the nth power. So 1 over x to the nth power, which, because 1 to the nth power is just 1, you end up with 1 over x to the n. Okay, let's go back over the properties of exponents. You should recall these from Algebra 2 and Pre-Cal if you took Pre-Cal. Given both m and n greater than 0, so we're talking about positive exponents here. The product property is a to the mth power times a to the nth power is equal to a to the m plus n. A to the mth power to the nth power is a to the m times n, and that's the power of a power property. And the power of a quotient property, a over b to the mth power is equal to a to the m over b to the m. The power of a product property is a times b to the mth power is a to the m times b to the m. And then quotient property, a to the m divided by a to the n is equal to a to the m minus n. Okay, so for example 1, we're going to evaluate or simplify as appropriate. No negative exponents should be in your answer. So we've got 125,678 to the 0 power. Okay, there's a property for this, remember? Yep, this is just going to be 1 because anything other than 0 raised to the 0 power is equal to 1. For b, we've got 3 to the negative 2 power. Remember that negative exponent means use the reciprocal, and so that's going to be 1/3 to the second power. So 1 squared is 1, and 3 squared is 9, so we've got 1/9. 3/4 to the negative 2 power, that negative still means use the reciprocal, so we're going to have 4/3, because that's the reciprocal of 3/4 to the second power. So 4 squared is 16, 3 squared is 9, and so our answer is 16/9. Okay, we've got 9m cubed n squared divided by 27m to the negative 2 over n, times n to the 5th. Okay, so let's see, 9 will go into 27 3 times. So those cancel like normal, so we're going to end up with a 3 on the bottom. Now I'm going to tell you a quick way to work with the exponents. You look at each variable, so I'm going to look at m by itself, then I'm going to look at n, and you look for where the larger exponent is. 3 is larger than negative 2, and the m to the third is on top, so my m's are going to end up on top. So I'm going to do m to the 3 minus negative 2. Then I look and I go, okay, my n's, I've got an n to the second power and an n to the 5th power. 5 is bigger than 2, so my n's are going to end up on the bottom. So I'm going to have n to the 5 minus 2. 3 minus negative 2 is 3 plus 2, so I end up with m to the 5th. I still have that 3 that I'm bringing down. N to the 5 minus 2 is going to give me n cubed. All right, I've got 2s squared t cubed to the second power. Those are all multiplied together, so we can just raise each different base up to the second power. So I'm going to have 2 squared times s squared squared times t cubed squared. So 2 squared is just 4. S squared to the second power gives us s to the 2 times 2, so s to the 4th, and t cubed to the second power is going to be t to the 3 times 2, so it's going to be t to the 6th power. So our final answer is 4s to the 4th t to the 6th. Okay, we've got x squared over y cubed to the 6th power. We have 2 different types of bases here, so we can't do anything to simplify on the inside, so we're going to go ahead and apply the outer exponent. So we're going to raise the top to the 6th power and the bottom to the 6th power. So I've got x squared to the 6th divided by y cubed to the 6th. Power to a power means I'm going to multiply my exponents, so I'm going to have x to the 12th over y to the 18th. All right, for any non-zero number b and any integers m and n with n greater than 1, b to the 1 over n equals the nth root of b, except when the nth root of b is not a real number. Okay, so if I have 64 to the 1/6 power, that's the same thing as the 6th root of 64. So what you want to do is you want to ask yourself, how can 64 be written as something to this 6th power? What times itself 6 times is going to equal 64? Well, since it's an even number, 2 is a good place to start, and 2 to the 6th does equal 64. So a power of 6 on the inside cancels with the root of 6 on the outside, and so we just have 2. Okay, we've got negative 125 to the 1/3 power. So that's equal to the cube root of negative 125. So we need to think of negative 125 as something to the 3rd power. It ends in a 5, so maybe 5, negative 5 to the 3rd power should work. Probably need negative 5 so that we end up with a negative product. Yep, negative 5 times negative 5 is positive 25, times another negative 5 is negative 125. So that works. So again, the cube and the cube root cancel, and so we have the value negative 5. Okay, so what about negative 25 to the 1/2 power? Well, the square root of negative 25 is not real. Okay, even roots of negative numbers are not going to be real. Odd roots like cube root, 5th root, that sort of thing, it's going to be real. For any non-zero number b and any integers m and n with n greater than 1, b to the m over n is equal to the nth root of b to the mth power, or the nth root of b to the mth power, which is going to usually be the easiest way for us to work with it, except when this little guy right here, the nth root of b, is not a real number. All right, so if I've got 64 to the 5/6 power, that means, by definition, the 6th root of 64 to the 5th power. Now, I'm not using a calculator, so I certainly don't want to have to do 64 times itself 5 times. So what I'm going to do is I'm going to do the 6th root of 64 first and then raise that value to the 5th power. Remember what the 6th root of 64 is? Remember 64 is 2 to the 6th? So this power of 6 and the root of 6 cancel and leave us with 2. 2 to the 5th, that's not so bad, that's 32. So much easier to do the root first and then raise to a power. Okay, I've got 81 to the 5/4, so I'm going to do the same kind of thing. I'm going to do the 4th root of 81 raised to the 5th power. Okay, it's easier to root and then power. All right, so 81 does equal 3 to the 4th power, 3 times 3 times 3 times 3. And so the 4th power and the 4th root cancel, and I'm left with 3 to the 5th, which is 243. Okay, guys, that's it for your lesson on exponents. Do the problems to try on your own. If you can't do them, either go back and rewatch part of the video or come in and get some help from me. But remember, you got to have those problems to try on your own attempted in order to get full credit for your notes. Well, thank you so much for your attention and for taking good notes, and I will see you in class. Have a great day.